The concept of left and right brain hemispheres is one of the most intriguing areas in neuroscience, offering a window into the specialization of brain functions. The brain is divided into two distinct hemispheres, the left and the right, each of which controls opposite sides of the body and exhibits unique cognitive processes. This idea is often simplified into popular beliefs like left-brained and right-brained thinking, though in reality, both hemispheres work together in complex and highly integrated ways. Historical context and hemispheric specialization. The idea of hemispheric specialization dates back to the 19th century with the work of French physician Paul Broca and later Carl Wernicke, who localized speech production and comprehension to areas predominantly in the left hemisphere. This set the foundation for understanding that different sides of the brain might control different functions. This view was later expanded through split brain research in the 20th century, particularly the studies of Roger Sperry, who showed how the two hemispheres could operate independently when the corpus callosum, the bundle of fibers connecting the hemispheres, was severed. Left hemisphere. The left hemisphere has traditionally been associated with language. It is often referred to as the language center. Broca's area, involved in speech production, and Wernicke's area, important for language comprehension, are located in the left hemisphere for most people. Analytical thinking. The left hemisphere is highly involved in logical reasoning, structured problem solving, and mathematical computations. This hemisphere excels in processing information sequentially, analyzing details, and working with patterns, sequences, and numbers. Linear processing. It tends to be linear and detail-oriented, focusing on individual components rather than holistic interpretations. It breaks down tasks into smaller parts and processes information step by step. Motor control. It controls the right side of the body, influencing actions like right-handedness, which is more common across the population. Right hemisphere. The right hemisphere, on the other hand, is more linked to creativity. It's often considered the seat of creative and artistic abilities, including visual arts, music, and the ability to appreciate aesthetics. It is involved in more abstract, divergent thinking, which leads to ideas that aren't always structured or bound by strict rules. Emotional and social perception. The right hemisphere plays a crucial role in interpreting emotions, both in recognizing facial expressions and understanding emotional tones in voices. It's more attuned to context, social cues, and nonverbal communication. Spatial awareness. It helps with spatial tasks such as geometry, recognizing faces, visualizing objects in space, and navigating environments. It allows us to process visual and spatial information more intuitively. Holistic processing. Rather than focusing on individual details, the right hemisphere perceives the big picture. It takes in the whole of a situation and can synthesize disparate information to form a cohesive understanding. The left-brained and right-brained myth. The common belief that people are either left-brained or right-brained is largely a myth. While it's true that some functions are lateralized, meaning they are more dominant in one hemisphere than the other, both hemispheres are constantly working together. For example, While the left hemisphere may handle grammar and vocabulary, the right hemisphere helps in understanding context, metaphor, and tone in language. Even tasks traditionally thought to belong to one hemisphere, like creativity, require the whole brain. Creativity involves not just the abstract thought of the right hemisphere, but also the structured, logical processes of the left. Similarly, analytical tasks might require intuitive leaps that the right hemisphere can provide. Communication between hemispheres. The two hemispheres are connected by the corpus callosum, a thick band of neural fibers that allows them to communicate with each other. This ensures that the brain operates as a cohesive unit, sharing information between its two sides. Without this communication, as seen in split-brain patients, the hemispheres can develop distinct functions and even conflicting behaviors. For instance, split-brain patients can perform tasks with one hand that their other hand cannot comprehend, highlighting how the two hemispheres can operate independently when severed. Hemispheric plasticity. While certain functions are more prominent in one hemisphere, the brain is remarkably plastic. For instance, if damage occurs in the left hemisphere, especially in children, the right hemisphere can often adapt to take over some of the functions, such as language. This neuroplasticity shows that the strict division of functions is not as rigid as once thought. Gender and hemispheric lateralization. Some studies suggest that there may be slight differences in how men and women use their brain hemispheres. Historically, men have been thought to show more lateralization of function, relying more heavily on one hemisphere for specific tasks, while women may use both hemispheres more equally, particularly in language processing. However, these differences are subtle and have been challenged by more recent research, emphasizing that individual variation in brain organization is much more significant than gender-based generalizations. Pathologies and hemispheric dysfunction. Damage to either hemisphere can result in specific types of cognitive deficits. Left hemisphere damage can result in aphasia, difficulty with speech production or comprehension, agraphia, difficulty writing, or apraxia, difficulty with motor tasks. Right hemisphere damage can lead to BISA, neglect syndrome, where a person is unaware of objects or even parts of their body on the left side of space. They may also have difficulty with visual spatial tasks and emotional processing. Integration and modern understanding. Modern neuroscience suggests that the brain's hemispheres are much more integrated than previously thought. Functional magnetic resonance imaging, fMRI, shows that tasks involve activation in both hemispheres. Creativity, for instance, is not purely a right brain phenomenon, but involves the interaction of many different brain regions. Likewise, logical thinking and problem-solving involve contributions from the right hemisphere, particularly when tasks require spatial reasoning or pattern recognition. This points to a more holistic view of the brain, where specialization exists, but cooperation and integration are key to most cognitive functions. Rather than viewing the hemispheres as isolated units, it's more accurate to see them as complementary components of a single, highly complex organ, each contributing unique strengths to a unified system. Conclusion. In summary, while the left and right hemispheres of the brain do show distinct specializations, language and logic for the left, creativity and spatial reasoning for the right, the idea that individuals are left-brained or right-brained is overly simplistic. The two hemispheres constantly communicate and collaborate through the corpus callosum, ensuring that cognitive tasks are handled in an integrated manner. Each hemisphere contributes to virtually all activities, from language and logic to creativity and emotional processing, making the human brain a marvel of both specialization and unity. Expand your knowledge and wisdom through short film documentaries like this one you just watched. Subscribe to The Philosopher's Canvas on YouTube and support us with a like and a comment. Until next time.